As you found out yesterday, it's the rectangular array of variables, horizontal rows and vertical columns, and it's always enclosed by brackets. Okay, the plural was matrices, and it's either called an entry or element, but it's basically each number in the matrix. Okay. It's named by the rows, by the columns. So matrix A would be, has 2 rows and 2 columns. So it's a 2 by 2. Matrix B has 3 rows and 3 columns, so it's a 3 by 3. And so C has 2 rows, but 3 columns, and that's okay. They don't have to be equal. Okay? They don't have to have the same row and column. They can be whatever. All right? And the elements are what's called indexed, and that's basically what that means is that they number them based on your row and column. So it would be like whatever your element, and the first number is what row it is, and the second number is what column it's in. Okay? So if I'm looking at matrix C, and I said, all right, what position is number 2 in? Okay, that would be my element A, and I'm in row 1, and I'm in column 1. So it would be element 11. That's just the letter that they pick for matrices. Doesn't really matter. Honestly, you can pick anything. So 2 would be is element 11. So like if I wanted to say, okay, well what element number is L? All right, so it's going to be element, it's in the second row, and it's in the third column. So L is element 23. Okay? Good with that? Okay. Then a square matrix is a matrix that has the same number of rows and columns. So like A is a square matrix, and B is a square matrix, but C is not, because it's not the same. There's only 2 rows versus the 3 columns. Good?
We call that
A square matrix? No. And honestly, it's, the only reason we need it to be square is for a method that we're going to use later on. It doesn't really matter. Okay, an augmented matrix. You guys, a lot of you guys had for your notes on there, or the ones who have submitted so far, had this line that you copy and pasted off the something for the definition of augmented, and it cracked me up because it's like I read it and I was like, I don't even understand what that means. So I have no idea. There's no way. It was like, that's making it so much more complex than what it is. But basically, an augmented matrix is the matrix used to represent a system of equations. Okay? So what you do is you take your system of equations and you take all of the variables, or I'm sorry, the coefficients, and you write them as a matrix. So column 1 or row 1 is equal to that equation. Okay? And column 1 is equal to your x's. Okay? Row 2 goes to your second equation, and row 3 relates to your third equation. The second column represents all your y's, and the third column represents your z's. Okay? And then you always put this little line here, that represents your equal sign. And then the last column is like your answer, whatever it's equal to. Okay? So you put all your variables on the left side of the equal side, and the constants go onto your right, basically. If you don't have a variable, like equation 2 doesn't have a y, and so you put in a coefficient of 0, you need that placeholder. Good so far? Lots of vocabulary. Yay? All right. The coefficient matrix, okay, is when you just use the one side of it. Okay? You only of the variables, all right? You don't use the answer, you don't put the thing. All right? And the main diagonal, it consists of the diagonal elements of the coefficient. So when you're looking at a main diagonal, you only look, it's going to be those numbers or elements in that position. And you only look at the coefficient ones. You don't care about like the answer side over there. Okay? Good so far? All right. Row echelon form is a matrix where the first row contains ones and only zeros below it. The A, meaning this A. Okay. The first non-zero entry in each row after the first is a 1. Okay? So like, that's my first non-zero entry. It has to be a 1.
So you should look down and to the right?
Uh-huh. It kind of follows your diagonal, basically. Okay? So it follows the diagonal. And then any rows that have all zeros are always at the bottom. This example doesn't have it. Okay?
What did you write about?
This is A for meaning this part, and then that's being following that. Okay? So basically, remembering this was like, if this is a system, this was my x's, this is my y's, this is my z's, right? If I put this back into my equation, I could say, hey, 2z is equal to 6. That means z equals 3. And then I can go back up to the next equation because now I have z and y is going to be solved. And then you go back up to the first line and then you can find x. Okay, so this is why we care about putting it in row echelon form, because that's how we're going to solve the system of equations. Okay? We'll get there. Don't worry. That's okay. We'll get there. Okay? Reduced row echelon form means that the main diagonal is all ones and the rest of the coefficient matrix is zeros. Okay? So I have all ones and then the rest are zeros. And again, thinking about this is x, this is y, this is z, that means that if I wrote this back to my equation, x is going to be 4, y is equal to -3, and z is equal to 1. So when we put it into this form, we can get our system of equation answers real easy.
Okay, I get how you solve, but what's the whole point of that?
Because we want the diagonals to be at ones, because then it's 1y is equal to -3.
So, so
Correct. All right. Okay. All of the information here on your Math Excel, questions 1 through 4 match up to this page. Oops, sorry. Snowman's in the way. I can't move. Right. Okay. All right. So let's talk about how we're going to get all those ones and zeros, because that makes it real handy dandy. And what you do is called row operations. Okay? Row operations, you can interchange any two rows. Oh, sorry, my bad. Okay? So this is the first one. Interchange any two rows. It says R2 is equal to basically row 2 is equal to row 1, which basically means that you're going to flip-flop 2 and 1, and row 3 remains unchanged. All right? So I can say row 2 is going to become row 1. That makes row 1 becoming row 2, and row 3 stays the same. All right?
now why did we change this?
Because it's just you're allowed to do that.
But
I'm showing you the rules
Why
of
do
what
you
you're
choose
allowed
that?
to do. Meyer, hi. Yes. Okay, will do. Bye. Goodbye, Chloe. Since you don't feel well, feel better.
No, seriously, no. Why did she not order them? Just
Why did I do row
because?
2 to row 1?
Yeah.
Just because, as an example. Well, when we get to this size, we're going to see why we would want to choose which. There's certain reasons why we want to choose. Oh, I want a 1 in this position. This row has it. I'm going to flip-flop the rows.
Okay.
That kind of thing. Okay? All right, so then row 1 comes down, but row 3 stays the same. Okay? That's one thing that you can do. All right, you're allowed to do. The second thing that you're allowed to do is replace a row by a non-zero multiple. Okay, so what that means is you can say, hey, I'm going to replace row 2 by whatever number you want to multiply by. My example, I chose -3, just because. All right? It doesn't affect row 1. It stays exactly the same. It only affects, for this one, row 2, and you have to do the multiplying to every single element. Okay? If you want to think about it as like I'm multiplying by -3, that's fine. So -3 times 1 is -3. -3 times -3 gives me 9. And -3 times -5 gives me a +15.
gives us the coefficient multiply.
Mm-hmm.
Is it just the bottom one? Or would it be?
Just for this particular, it was choosing row 2.
Okay.
It
If
just
it was row one,
depends.
you do the same thing.
You do it, that's just to show you can do it with whatever you want to do. Okay? All right, and the last one for 3, you can basically combine the two. All right? So what this is saying is I'm going to take row 2 and I'm going to multiply row 1 by a number, and then I'm going to add it to that row. And you can do that. All right, so I start with my row 2, and I have to do it for every element. And so for the first one, I did 9 times 1, because that's row 1. And then I added it to row 2, so 9 plus a negative 9 gives me a 0. Okay. So now my second one, I take 9 times 5, which gives me 45, and then I add it to row 2, which gives me 6. So 45 and 6 is 51. And then I do it one more time. So 9 times negative 9 is negative 81, plus a negative 2 is going to give me negative 83.
And then they already have the numbers like preset in them, right?
Yeah,
On a regular equation, or is it?
Yeah, and that's what we're going to do right now. So for this one, okay, so I want row 1 to become this operation. All right? So that means that row 2 and row 3, absolutely nothing happens to them. All right? I'm only dealing with row 1. All right? So I'm going to multiply row 2 by negative 4. So I have negative 4. Row 2 is 2. And I'm going to add it to my row 1. So I would have negative 8 plus 9. So my new element is 1.
Where did you get the plus 9 from? Oh, the first
Because I added row 1. So for my second element, I'm going to do negative 4 times row 2, so that's negative 4 times negative 5. And then I'm going to add row 1, so I'm adding a negative 2. So I get 20 minus 2, and so my second element's 18. Okay, good so far? Okay. Got to do it for each position. So for position 3, or column 3, I'm going to do negative 4 times row 2, so negative 4 times 7. And then I'm going to add row 1 and add row 1. So I'm going to have negative 28 plus 1, which gives me negative 27. One more time. So, negative 4 times row 2 is going to be negative 4 times negative 2. Add row 1, minus 2. So I'm going to have 8 minus 2. And so my final one's 6. 3 in column 1 and column 2. That's what we're going to do. Okay. Math Excel. I think it's question 5 and 6 are on these two. Doing row operations. And Izzy's question was, why do we care? Do we have to do this? Do we have to do this? We care because we want to get it into row echelon form. Okay? So, here's your first step. We need to write the augmented matrix. Okay? So, augmented matrix was going to look like what? We're going to have a bracket. First question, what kind of matrices, how many rows and columns am I going to have? I got 2 rows, and I'm going to have 1, 2, 3 columns. So I'm writing a 2 by 3. Okay? All right, so my first column is going to be a 2 and a 3. That's like going to be my x's. My y column is going to be -6 and -9. And then that part right there, that's my coefficient. And then I have 8 and 12. Okay? Okay, so the next step is, remember, our ending goal for this one is that we want it to look like this. We want ones in the diagonals. Okay? So the first step is to do a row operation that gets a 1 in that first position. All right? So basically, if there isn't a 1 anywhere else, you're going to multiply your A11, your first element, by 1 over A. Okay, so my element is 2, right? Since A is equal to 2, that means that my row operation is my first row is equal to 1/2 of row 1. Good? All right, so 1/2 of 2 is 1. Good, because that's what I wanted. 1/2 of -6 is going to be -3. And 1/2 of 8 is going to be 4. Didn't do anything with the second row, so it just kind of comes along for the ride on this one. Okay. All right. Now, we want to get to 0 in the second position. Okay? So that's step 3. And you're going to multiply row 1 by its opposite. And then you add it to the row. Because row 1 is a 1, you know you're always going to get that opposite number to make it go away. Okay? So that means that my row 2 is going to be, I want the opposite of 3 is -3. I'm going to multiply that by row 1, and then I'm going to add it to row 2. So, row 1's going to stay exactly the same. I'm just going to go ahead and put that in there. Okay. And so now I just have to multiply each. So for my first element, I'm going to have negative 3 times 1, because I multiply it by row 1, and then I add row 2. So negative 3 plus 3 is going to give me 0. Exactly what I wanted.
Where's the row 2 at?
Row 2 is going to be my 3, negative 9, 12.
Oh,
Okay? So for my second element, I'm going to have negative 3 times row 1 of negative 3 and minus 9. So I get 9 minus 9. That gets me a 0. And then my last position, I have negative 3 times 4 plus row 2. So I get negative 12 plus 12. Hey, that gives me 0. Okay. Now, at this point, anytime you get something that looks like that, if you put that back into an equation form, that's like saying 0 equals 0, right? What kind of solution do you have? All solutions, right? And then you'd have to put everything in terms of like y is equal to all real numbers. And then we would solve x. So 2x minus 6y equals 8. Hi. So 2x is equal to 6y plus 8. And so x is going to be equal to 3y plus 4. Remember that part? Okay. It's okay. It's okay. Let's do one more. Okay, let's go to the next page. Okay. All right. Here is my system of equations. I have x minus y plus z is equal to 8. And then I have 2x plus 3y minus z is equal to negative 2. And I have 3x minus 2y minus 9z is equal to 9. Good? Okay, so first step, write my augmented. So, my x's are going to be 1, 2, and 3. My y's are going to be negative 1, 3, negative 2. And my z's are 1, negative 1, and negative 9. And then the answer, total columns, whatever, is 8, negative 2, and 9. Everybody feel solid about writing the matrix? That's good. Okay. All right. So remember, the end goal is I want to have 1, 0, 0, 0, 1, 0. Well, actually, I'm not going to worry about those. And then 1. I want my main diagonals to be 1s and the triangle underneath it to be zeros. That's my goal. Okay? So, let's look at the first thing I want is a 1. Hey, look, I already have a 1. Woohoo! That makes life good. Okay? So now I have to get a 0 here. Right? So, what can I do to get it to a 0? Multiply, that goes back to get to a 0. You're going to multiply your row and then add. So let's make row 2 become a -2 times row 1. And then we're going to add it to row 2. Okay, good. All right, that means row 1 and row 3 aren't going to change. You don't have to put them in right away. I do just so I don't forget something or mix up my numbers. All right, now let's perform the operation. So row 2, so -2 times 1 plus 2 gives me 0. Second position, -2 times -1 plus 3 gives me 5. -2 times -1 gives me 2, because I'm in the second position.
Yeah, I know, but I said, with multiplying -2 by row 1. Okay, never mind.
Okay. All right, third position, I'm going to have -2 times row 1 of 1 plus row 2. So I'm going to have -2 minus 1, and I get -3. And then I have -2 times -2, times 8 minus 2. So I get -16 minus 2 to -18. Good. All right, I got 2 more to do. I got get these down. We're doing good. So now I need to get row 3 as a 0. So to make a 0, I do the same thing again, but this time I'm going to multiply by what? What's the opposite of 3? -3. So -3 times row 1, and this time I'm going to add it to row 3.
Why is it row 1?
Because row 1 has a 1, and so I know I'm going to get that opposite sign to make it equal 0.
That's not always row 1.
It will always be row 1 at once you have a 1 in that position. Then no, you can use any number you need to get to whatever you want. Okay? All right, so here we go. Row 1 and 2 aren't going to change. So I'm going to go ahead and put those in. And then I'm going to perform the operations. So I have -3 times 1 plus 3 gives me 0. Okay. -3 times -1 plus a -2 gives me 3 minus 2, or a 1. Then I have negative 3 times 1 minus 9, which is going to give me negative 12. And then last I have negative 3 times 8 plus 9. So that's going to give me, what, negative 15? Okay. All right. Hey, look. We love ones. All right, because remember, I want to get ones in all my positions. I have a 1 here. So you know what? I'm going to replace row 2 with row 3. I'm just going to flip-flop those rows. I'm allowed to do that. That was the very first one we learned. So row 1 stays the same. And row 2 becomes row 3. And now I'm almost there. I just need those 3 to be zeros. Okay, so what should I multiply by to get this to be a 0? That goes back to my negatives. Anytime you're trying to get zeros, multiply by the opposites. So if I make row 3 then a negative 5, and I can do it times row 2 this time. That'll make it even faster because there's a 1 right above. That's going to work. And add it to row 3. It's way down here. So row 1, gonna stay the same. Row 2 is gonna stay the same. 0 times negative 5 plus 0 is going to stay 0. So negative 5 times 1 plus 5 gives me 0. And then negative 5 times negative 12 plus negative 3 is going to give me 60 minus 3 is 57. And then negative 5 times negative 15 minus 18. So 75 minus 18 gives me 57? No, that's not right. Oh, yeah. Okay. I have these here, and I have my 2 1s. So if I rewrite this into my equations, I would have x minus y plus z equals 8. Y minus 12z is equal to negative 15. And 57z is equal to 57. Everybody with me on that? Okay, so what's z equal to? 1. Then move back up to the equation. So y minus 12 equals negative 15. So y is going to be negative 3. Move back up to the top one. X plus 3 plus 1 equals 8. And x is equal to 4. So 4, negative 3, and 1 ends up being the answer to our system.
They all didn't zeros and ones.
We only need to do the first corner here and the top two ones. Because then we have, so that this is equal to, z is equal to a certain number, and we can just solve, we can just solve the equations then, put it back into the system of equation form and solve by going back up.